line, but I'm going to start back.
Which one is that?
This is the one with nothing on the back tire. This is a factory release model. How far do you think it's going to go?
Wow.
All the way to the wall. Okay. So let's just leave it where it is. Sandpaper. More friction or less friction?
More friction.
Okay. Friction depends on both surfaces.
I don't think it's going to go as far.
It depends on the reaction between one surface and the other. We're going to do the same thing. All right, so there definitely was not much of a difference. Wax paper.
Oh, not as far.
Less friction, right? So it's a waxy surface and a waxy wheel. So what did it do? Did you hear it?
Yeah.
It spun out in the very beginning. Oh, I'll do it again. Okay. So when you make a decision about the tires you want to use, you have to think about the surface your car is going to be pulling on and that coefficient of friction between those two materials. If this were carpet, we might get the wax paper which is fine on carpet. I don't know. Or if it was asphalt, it might work just as well on asphalt because there might be a higher coefficient of friction. So there's a way you can test your different wheels that are in your kit to see how much friction each wheel has. Can you think of a way you could test the friction of your wheels themselves? You've got a spring scale, and you want to test the static friction or the sliding friction, right? Not the rolling friction, because that's going to be negligible. So how could you set up a situation where you can see how many newtons of friction it takes to get a tire to move? You could even have the tire on a string and put Unifix cubes in a bucket and see how many Unifix cubes it takes to slide that tire. But you don't want the tire to roll. There's a special piece in your kit. It's a special little Lego that you can put a shaft through and it won't turn. And you can set that up with some wheels on it and pull on those wheels with your spring scale, or tie a string and put a bucket and drop cubes in the bucket and see which wheels have the most friction, because you want to have enough friction to grip the floor to pull that bucket of seabird eggs, or else it will spin out. You'll shine the light on and those back wheels will just start spinning and they won't go anywhere, they won't grip. Do you know why race car tires are flat with no bumps on them? If you go to the NASCAR race, if you look at the car tires on a race car, do you know why they're completely flat and they look like they don't have any friction at all? More contact. They're wider, but they also spin them to get them hot and they get sticky. They get hot and sticky, which gives them more friction, but not so much that they can't move, but enough that they can really grip the ground better, and when you step on the gas pedal, it won't spin out. So we want more friction. And when I walk, if I don't have friction, my foot will I'll do the moonwalk, I'll do the Michael Jackson moonwalk. When you walk, in order to go forward, I need a frictional force pushing me forward. Friction is pushing me forward. Without friction, I wouldn't go forward. My foot's trying to go back. I'm pushing my foot back, but the friction is opposite and is pushing me forward. So people think of friction as the force that opposes motion. In the case of walking and in the case of cars, friction is the force that pushes you forward. When the wheel is trying to go the opposite way, the friction counteracts it. Does that make sense to everybody? Go through the square, it won't turn, and you can put wheels on both ends, and then you can pull with your spring scale here and get the friction, or hang a string in a cup.
There was where it first started getting movement.
So keep going.
Well, that's all we needed to know was when does it
50?
start moving. Yeah, pull it just a little more.
Okay, it's on 0.